To add two polynomials, we write a plus sign between them and combine like terms. So here we have two polynomials added together. We can write these without parentheses since it's addition of these two polynomials. Be sure you include the signs as they are given here. Next, we will use commutative and associative laws to write like terms together. A similar term to the first is here. We have a plus 3x to the fifth, since both of these have x to the same power. We have an x to the third, and a similar term here with the negative 4x to the third. We have a negative 9x, and we have a 2. When you're rearranging your terms, putting like terms together, be sure you don't lose some term from the original polynomial. Now, combining like terms, we'll use the distributive law by adding those coefficients of the like terms. 7 plus 3 is 10x to the fifth. A positive 1 minus 4 on our x to the third results in a negative 3x to the third. There's nothing to combine with the term here. There's no other term with x to the first power, and there isn't a constant term, so we'll leave those last two terms as is. Here we have an equivalent expression for the sum of those two polynomials. To add using columns, we write the polynomials one under the other, listing like terms under one another and leaving space for any missing terms. And that's a good technique where this type of problem occurs. We're adding not only two polynomials, but we have a third polynomial. So let's take a look at a vertical addition or using columns. So we'll write that first polynomial, 9x to the fourth minus 8x to the third plus 6x squared. If you notice, I don't have an x term, so I'm going to leave a space and slide that constant term over. The next polynomial has a 5x to the third. I'll place that underneath the similar term, and it has a minus 3x. That's the space that it provided. The last polynomial has a squared term, x to the second power, so I'll put that lined up with the x squared, and then it has a constant term. And the instructions are to add these together. There is no similar term to add to our 9x to the fourth power. However, x to the third, if we use our distributive property to simplify, negative 8 plus 5 leaves a negative 3, the difference between those two numbers, the larger being absolute value being negative, so we have a negative 3x to the third. Here we have similar terms with our x squared, 4 and 6 give us 10x to the second power. There is no other term to combine with the x terms. We have simply negative 3x, and our constant terms, when combined, negative 5 plus 7 results in a positive 2. Thus, we have the sum for the addition of those three polynomials.